afternoon, everyone, and welcome to our latest episode of MSME Masterclass. Today's speaker brings a rare hands-on perspective to the topic of material integration in steel buildings. Please join me in welcoming Mr. Suyash Yadav, Director of Skyhub Partitions, a company that has been innovating in the space of aluminium glass steel interface systems for over 30 years now. Suyash leads operations at Skyhub Partitions, which runs in-house aluminium extrusion, powder coating, anodizing, and glass tempering facilities, all tailored to interface seamlessly with steel structures. His expertise lies in making these systems not just architecturally elegant, but also structurally reliable and site-ready. With 15 years of direct experience plus a strong background in automation engineering and an MBA from JBIMS, Suyash blends precision fabrication, smart sequencing, and deep material knowledge, all of which are essential to industrial MSMEs building the next generation of durable, high-performance steel buildings. Let's hear from him on how MSMEs can level up their execution through better material integration. Welcome to our MSME Masterclass, Suyash. Pleased to have you with us.
Thank you so much for introducing me. Thank you. It's my privilege to be with you.
Thank you. We'll move on to the first question that we have for today's session, Suyash. When we say material integration, in the context of steel buildings, what exactly are we referring to?
So basically, material integration refers to designing, detailing, and executing steel structures together with other materials like the aluminium you take, glass, the concrete, ACP panels, claddings. So all are as one coordinate, they act as one coordinated system, not as separate add-ons. So basically, you just consider that steel is the primary skeleton, but other material work with it mechanically, thermally, as well as visually. So we have to be in practical. So we have to understand the load parts, understand the load parts across the metals. The load parts would be different for the aluminium, for the glass, and for the steel. So thermally it is different. Connections are compatible. We have to look over there, as well as the tolerances, the movements, and the finishes has to be coordinated. The installation sequence that has to be done, it has to be pre-decided. So for better planning, it is much better.
Understood. Now, given your experience, Suyash, what's the one most overlooked aspect that, when integrating non-steel materials like aluminium and glass with steel frames?
So, according to me, the most overlooked aspect is the movement and the tolerance mismatch. So, when the designer designs, they align the material geometrically, but forget that different materials has different thermal expansions. Like aluminium actually expands as much as twice the steel. So, we have to understand that the steel is forgiving. It is rigid. Steel is forgiving, but the glasses are not. The glasses are fragile and brittle, so they break. So any failures can mismatch, can actually create a huge impact, and the cost can increase. Ignoring this can lead to actually the cracked glass, the warped aluminium frames, or the stress at the fasteners.
Okay. And at what stage in the design or fabrication process should MSME start thinking about material compatibility?
It should actually be thought at the concept at the preliminary design stage, but not after the fabrication of the drawings and all. It should be at the preliminary stage. So when like the grids, the columns have been decided. So before that, everything, the spaces have been frozen. Before that, it should be decided. So if it is decided on a later stage, then basically you have to rely on the jugards that usually people do, and because of this, the quality and the durability suffers, and the cost also increases due to this.
Suyash, because you work very closely with aluminium and glass, tell us what unique challenges do these materials pose when paired with steel structures?
So basically, the aluminium has high thermal expansion. And when the aluminium and steel contact each other, then there's a galvanic corrosion happening. So for that we have to take care. And for the glass, if we have like zero tolerance for the movement or distortion, then it might break. The glass requires acute precision for the alignment. For the glass, the edges of the glass needs to be taken care of, because The toughened glass usually breaks from the edges, not from the center, so we have to take care of the edges. So again, I will be saying the same thing, that steel is forgiving, aluminium is okay, but glasses are not.
Right. And in steel buildings, tolerances really matter, right? How can small fabricators improve alignment between different material systems?
So the fabricators can use the datum lines and their reference levels, so that will help them. And by prefabricating the mock-ups of the critical joints, so what happens, instead of getting the failure on the later stage, it is much better to have a look at the critical stage. Then also the another point would be coordinating the shop drawings with the facade vendors, because this is one of the most important point that many actually avoid or tend to miss this point. Then they can invest in jigs and the small fixtures which are low in cost but has high impact, and and also they might use the adjustable brackets or the slotted holes.
Okay, got it. What fastening or jointing methods have worked best for steel aluminium interfaces in your projects?
So according to me, the stainless steel, that is the SS, is the best thing. It avoids the galvanic corrosion that we mentioned earlier, that the aluminum and steel can give the galvanic corrosion. So SS can avoid that. Then the isolation layers, the glass should not break. Then they can use the EPDM and the nylon washers, that can also help, and also the sliding or the slotted connections to allow the easy movements. And one more thing, the bolted connections are preferred over welding. Never weld the aluminum directly to the steel.
And when you say that, why would you say that?
Because the bolted connections, it for the easy movements and all, otherwise the stress happens.
Got it. Now, how can MSMEs manage thermal expansion differences between steel and other materials like glass or aluminium?
So the key strategy is like to provide the movement joints. So again, if the movement joint is there, the sliding and the floating connection is proper, and by avoiding the rigid fixing at both the ends, and by using the gaskets, the nylon washers, the setting blocks, and the flexible sealants, that will help. And also one thing, that separate the structural support and the facade restraint from the facade restraint. So the thumb rule is basically steel holds, aluminium moves, glass floats.
Okay, that's great to know. For MSMEs building industrial sheds or modular units, what should they keep in mind when working with multi-material facades?
So steel primary frame remains structurally independent. It should be structurally independent, not dependent on the glass or the aluminium. And the panels, the glass systems are the secondary steel. So they are not the primary ones. So then focus on the drainage and the sealing. So they are also as important as the strength, because if over a period of time, if the drainage and the sealant has not been taken care of, then that might lead to the failure on the later stage, not now, but few years down the line it might happen. And the another important thing is the installation sequence must be defined properly.
According to you, Suyash, what role does surface treatment like anodizing or powder coating play in long-term durability when combining materials?
So the proper applying of the chemicals in the aluminium powder coating and the anodizing, a proper micron, like the anodic microns would be up to 25 microns. From like a range of 20 to 25 microns is much better. The powder coating on the other hand should be in the range of 60 to 80 microns. So and on the MS it is more than 120 microns. on the steel. So that thing we have to take care of. If all the process has been taken care of, then it helps prevent corrosions, reduce galvanic reaction, improve aesthetic as well as the lifespan. For example, if the powder coating material, powder coating aluminium and the galvanized steel is paired, then it forms a safer pair when it is properly anodized and galvanized. Similarly, the anodized aluminum performs better in the industrial environment. So bad surface treatment will lead to the failure in the later stage.
Okay. And according to you, tell our attendees, are there common errors that you've seen on site where material integration has failed due to planning gaps?
So the first thing we have to understand that most failures are due to planning issues, not material issues. That is the foremost thing. So the typical errors usually happens is like steel is erected without facade reference point. That is, we have earlier discussed about the datum lines and the reference levels. So that we have already spoken. So we have to take care of that. There should be no allowance, like during the glass, the movement should be restricted. It should not be easily moving. The aluminum fixed rigidity to steel, as well as they have to use the proper stainless steel fasteners, the SS fasteners, not the other ones.
And tell us what coordination is required between the steel fabricator and the secondary material supplier to avoid clashes during installation.
Okay, so as I mentioned earlier, the planning should be together. Planning should be done together. The drawings should be shared along with the tolerances, so that on a later stage again, when the progress goes on the later stage, there should not be any hiccups. The load and the fixing responsibility clarity should be there between them. Sequence of installation is very again important. The agreed datum or the reference point that was been taken, it should be maintained. It should be strictly followed. It should not be haywire here and there. Another thing, the regular coordination, the meeting should happen so that the clashes among the working agencies should be avoided.
Could you also share a project where project of yours or any that you've known of where thoughtful integration between steel and another material improved both function and finish?
Yeah, so there was one project of ours in Kolkata. So over there, we had used the steel beams were aligned with aluminum mullions properly, and because of that, the composite slabs and the panels were actually, the deflections were reduced and the glass facades was adjusted on the adjustable brackets. So due to this, there were no glass breakage on us. Like, it was a building of near about 21 odd story, and there was no glass breakage over there. The facade was looking much cleaner, and the installation was much faster, and the thermal performance was also better.
All right. Suyash, we've seen many MSMEs still view steel as a standalone system altogether. Now tell us, how can they build the mindset to design for integration?
So I think that they have to think steel structure first, others later. To the steel is the backbone of the multi-layered system, multi-material system, you can say. So there, the mindset has to change. So this comes from early coordination. Then you can say the learning from the facades and the glazing trades. So people can have some meetings with the facade guys, so that the better things can be understood on the front hand itself. Then investing in the detailing skills, you might say that even the spending on the what you can say, spending on the trainings, that is one of the four most important thing that should be done, because that is quite lacking over here in the MSMEs. That is what I feel.
You say training and educating our staff is very important.
Yeah, right.
Got it. Is it more cost effective, Suyash, to fabricate everything in house as your firm does, or can MSMEs outsource while maintaining integration quality?
So, of course, the in-house gives you the better control over the quality and the turnaround time. It can be much faster. If there is any issue or any quality concerns, you can get a faster feedback in that. Ours, like if there is an issue in anywhere, then the coating or the energizing thing can tell us that this is an issue and you can get solved. The higher integration quality should be there. Outsourcing also works actually, but over there the drawings must be clear. The drawings should be clear. The quality checks should be stricter, and TPA, third party inspection, should be done every now and then, and the interfaces should be defined. So the integration quality moves more on planning rather than ownership.
But you're saying the turnaround time would be lesser if you do it in house.
Yeah, true.
Okay. With rising project complexities, how can MSMEs balance design ambition with practical execution in hybrid material buildings?
So the main thing I feel is practically we should standardize the details. The details should be standardized. Avoid over customization. Due to the over customization, like the client needs everything on integrities, but we have to draw a line that this can be done, this cannot be done. So over customization every now and then should be avoided. Then prefer using repeated modules. So the cost effective it will be cost effective, and the prototypes where the critical joints are there, which might lead to failure. We should first try to make a replica of the small prototype so that it becomes easier for us on the little scale. And another thing, ambition must match fabrication and site capability. It should not that I can make this and I should look like that.
About personalization, and you shouldn't overdo it. To what extent, according to you, is personalization okay, and it's not okay? Where should one draw the line?
So there is basically there are some other radius. If suppose the client requires a radius of less than 300 but that is practically not possible. And if we say okay to that, then the bending of the aluminium, the profile bending, the glass curvature becomes a challenge, and then you cannot put a toughened glass over there. Then we have to give the non-toughened glass. Then that might be a problem on a later stage. The non-toughened glass can break anytime, and that might lead to danger situation.
Got it. Tell our attendees, how do load paths or structural stress points influence decisions when using glass or aluminium partitions within steel buildings?
So the first thing is, like as I mentioned earlier as well, glass should never carry the structural load unintentionally as well. If it carries, then the glass will break. It should be like aluminum partition even the aluminum partition should not brace the steel frames unless it is designed to do so. Otherwise, and even the steel deflection must be limited where the glass is attached. Again, otherwise the glass might break. So if the structure moves, then the finishes cracks. So we have to take care of that.
All right. According to you, Suyash, what kind of design detailing is critical to avoid leakages, corrosion, or misalignment in mixed material installations?
So the most long-term failures begin at interfaces, usually where the joineries are there. So the important details to be taken care of at the proper flashing and the drip edges. The edges should be taken care of. The isolation between the dissimilar metals like the aluminium and the MS should be taken care of. The drainage path should be properly designed. The adjustable fixings should be properly done. So those are the points that we need to take care of.
Now, tell us how can MSMEs educate, because this is something that we touched upon, training, education. Tell us how can MSMEs educate their site supervisors and welders on the nuances of handling and installing non-steel elements.
So it's better to, as I told you earlier, that as we discussed earlier, that we should plan for a better training things. So it helps on in evolving the staff around us. Then the effective methods that you can say is like the toolbox talks focused on mixed material. So how we should use that. Then provide the visual installation guides to them. So even the mock-up demonstration should be done to for the less failure chances, and clear do's and don'ts should be done. Like no welding should be done ever near the glass. Otherwise, there are white spots on the glass due to the welding spots.
Got it. Got it.
And also one more thing we can add. Sorry, penalize on site on site supervisors to improvise the damage finishes, so that it has been taken care of better in a better way, because skill upgrade is important as material selection.
Understood. In terms of codes and standards, are there any integration guidelines that smaller businesses should be aware of?
So according to me, personally, codes define safety. Details define success. So there are IS standards, IS 800 for the steel, then there are ASTM and ISO standards for the power coating and anodizing. Then there are IS standards for EN standards for the aluminum as well. The facades and the glazing guidelines is IS 16231. We have to take care of that as well. The fire and the corrosion protection should be taken care of. The standards are there. The manufacturer system manuals are there. So there are quite IS and BIS standards as well. But according to me, codes, again I will say, code defines success, codes define safety, but details define success. So detailing should be taken care of.
Okay. And if an MSME is just starting with engineered steel buildings, what is your number one tip for getting material integration right?
So it would be design the connection before you design the component. Because again, metal integration is not an add-on. It is the core design discipline. So if all the interfaces are right, the material cooperates, the installation is properly done, smoothly done, the performance lasts, and there will be no issue. It would be a better quality as well.
And finally, Suyash, just for our attendees, can you share, best case study, best use case scenario of material integration in steel buildings that you know of?
So as I told you earlier, like we had done a project in Kolkata. We were very fortunate, or we actually followed all the rules and all the things. So we didn't had even a single glass breakage over there. It was a semi-unitized system, and it was properly done. As I said, the aluminum, the profiles and the steel coordination was done so smoothly, then automatically there were no issues over there in that building. So all the finishes were clear. It's been since last 2.5 years we have done so, but till now we are very fortunate that no complaint has been raised till now.
Got it. Suyash, with that, we've come to the end of today's episode. Thank you so much for being with us and for sharing your insights on material integration in steel buildings. Thank you. It was lovely having you with us.
Thank you so much. Thank you. Pleasure was mine.
For our attendees who are online, if you'd like to view the current episode, if you've missed any part of the current episode, please go on YouTube, type GSW1 MSME, and you will find all our episodes uploaded there. Thank you once again, Suyash. Bye-bye.
Thank you. Bye.